This is a problem worked through for problem number 13 in lesson 3.6, Newton's second law of motion. Charlie, whose mass is 100 kilograms, skydives and parachutes from a stationary helicopter. 5 seconds into the drop, the air resistance on Charlie is 200 newtons. So for step 1, we need to complete a free body diagram and find the net force on Charlie. So let's start with our laundry list. Let's identify all of our information first. So our mass, the mass of Charlie is 100 kilograms. We have a time of 5 seconds. And we know that air resistance, well, let's see. Yeah, air resistance, FD, is going to be 200 newtons. We also know, since we're on Earth, since he's skydiving on Earth, that the acceleration due to gravity is going to be 10 meters per second squared. So that's all of the information that we know. Now let's do a free body diagram. So our free body diagram, if this is Charlie skydiving out of the helicopter, we're going to have gravity pulling him downward, and we're going to have air resistance pushing him upward. But what is his weight? What is his net force? Well, in order to find his net force, we need to know what his weight is. So the weight is equal to the force of gravity multiplied by mass times the acceleration due to gravity. So 100 kilograms multiplied by 10 meters per second squared. That gives us a force of gravity of 1,000 newtons. So net force for Charlie is going to be 1,000 newtons downward minus 200 newtons upward. So we have a net force of 800 newtons downward. Now, if we want to solve for Charlie's acceleration, we're going to need to do a slightly different formula. Now, let's just rewrite our laundry list so we know what we have. So we know that the resultant force, the net force, is going to be 800 newtons. We're looking for acceleration, and his mass is still the same. It's still 100 kilograms. Now, it's Newton's second law, force equals mass times acceleration. If we solve for acceleration, that means we're going to divide both sides by mass, and acceleration equals force divided by mass. So acceleration equals force over mass, which is 800 newtons over 100 kilograms. I don't have quite enough room, so 800 divided by 100 is 8 meters per second squared is Charlie's acceleration. Now, this makes sense because he's being slowed down due to the force of the air resistance upon him. So we know that gravity is 9.8. We call it 10. So he's being slowed down by almost 20% to get down to 8 meters per second squared.